Okay, today we're going to be doing 3.7, direct variation and linear regression. Direct variation represents a linear relationship. Let me fix that. Okay, let's try this again. Okay, direct variation represents a linear relationship. And then the next part says y varies directly as x, or y is directly proportional to x. So whenever you see that verbiage or those words, y varies directly as x or y is directly proportional to x, you're going to think of this equation, this direct variation equation. It's y equals kx. And let's go ahead and write what these represent. So k is called the constant. So it's called the constant of variation or the constant of proportionality. So if you noticed in those keywords above that I pointed out earlier, y varies directly as x. Well, in that, k is your constant of variation. Y is directly proportional to x. Well, k is the constant of proportionality. Now it says when comparing direct variation to a linear equation, k is the slope. So we've worked a lot with slope, so you should know what slope is. And remember, slope is the change in y over the change in x. And there's another little note I want you to write down, something important to notice. That a direct variation equation, so let's write that down, a direct variation equation always goes through the origin, which you should remember is 0, 0. So remember when we found slope, we always had to do y2 minus y1 over x2 minus x1 because we had two sets of points. Well, we are going to be given a set of points, but the other set of points will be 0, 0. So therefore, k always equals y over x because we don't have anything to subtract it from. So let's go ahead and do number 1. We have k here. Well, we see we are given an x, make this a little bigger, and we're given a y, and k equals y over x. So let's put 8 over negative 4, and you must simplify, and that would be negative 2. Therefore, if k equals negative 2, our equation is y equals negative 2x. Let's go ahead and go to number 2. Write the direct variation equation that goes through 3, negative 9. So 3 is our x, y is our negative 9. Therefore, our k will be negative 9, which is our y, over x, which is our 3. And we simplify that to negative 3. Therefore, y equals negative 3x. Let's go ahead and go into number 3. Suppose y varies, now here's that terminology, y varies directly as x, and y equals 16 when x equals 8. So now it's saying it wants us to find y when x equals 16. So let's go ahead and set this up. First thing you're going to do, so let's go ahead and write number 1. First thing is find equation. So let's find the equation. So we have k equals, remember y over x, so that's 16 over 8, which equals 2. Therefore, that's y equals 2x. Or I'm sorry, 2x. Let's make that an x, not a k. Y equals 2x. Now, the second thing you're going to do is plug the given value. So let's write this down. Plug given value into equation and solve. Okay, so now let's go to this next part. So we have y equals 2x. So let's go ahead and plug in what they give us. Well, we have y. They didn't give us a y, but they did give us an x. So let's plug in 16 for x. Therefore, y equals 32. Now let's go ahead and go to number 4. Now it says, suppose, I'll use a different color. Suppose A is directly proportional to B. So again, we saw that at the top in that box. And we have A equals 7 and B equals 2. Well, notice we don't have X and Y. They're using A and B. That's okay. We're going to use them the same way. So A is our Y, B is our X. And let's go ahead and put those over here. A is our Y here, B is our X. And same here. B is our X, A is our Y. And we're going to do the same thing we just did at the top. Y equals y over x, which would be 7 over 2. And let's go ahead and put that in the equation. Y equals 7 over 2. Instead of x, we're going to use a b. And let's plug in what we're given. We are given a y equal to 21 equals 7 over 2. And we need to find b. That's what our question is asking. Find b when a is 21. So we have to get rid of this fraction. So we multiply it by the reciprocal times 2 over 7. And let's go ahead and pull this up so we have a little more space. These cancel each other out. So now I'm left with b equals 42 divided by 7 is 6. So b equals 6. Let's go ahead and go to the next page. Now it says a local food restaurant takes $9,000 in a 4-hour period. So our $9,000 will be our y, 4-hour period will be our x. So it says write a direct variation equation for the relationship between income and number of hours. So a direct variation, therefore we're going to have k equals y over x. So we have 9,000 divided by 4. And that comes out to 2250. And you could use your calculator for this one. So therefore, y equals kx, and our k is 2250 x. And again, we know we're going to use direct variation because it says right there, direct variation. Now it says estimate how many hours it would take the restaurant to earn $20,250. So we want to earn $20,250. So how many hours would that take? Well, let's do our 2250 times x. Again, our y is 20,250. So that's why we put it over here for our y. And our equation is the y equals 2x. Okay, so let's go ahead and get x by itself. So let's divide by 2250 on both sides. And with your calculator, you can go ahead and divide that, and you will find you will get 9. Therefore, our answer is 9 hours. So for this next part right here, it's a scatter plot. A scatter plot is a graph of a set of data pairs, x, y. If y tends to increase as x increases, then the data have a positive correlation, a positive slope. So we can see, let's just finish reading. If y tends to decrease as x increases, then the data have a negative correlation, a negative slope. If the points show no obvious pattern, then the data have approximately no correlation. The correlation coefficient is r. So positive correlation, again, you can see that y tends to increase as x increases. And we have that increase right there. That's a positive correlation. Therefore, R would be close to 1. That's a positive 1. For the next one, the negative correlation, if y tends to decrease as x increases, then the data have a negative correlation. Therefore, it's a negative slope, so we'd have negative 1. And then no correlation. Notice how all the points are all over. We can't really get a positive slope or a negative slope. So R would be close to 0. there would be no correlation. Now for this part, let's go ahead and see if we can identify this. So for each scatter plot, determine if the data have a positive, negative, or no correlation. So for number 1, we can see the dots are all over. There's no pattern here. They're just kind of all over. So we're going to put no correlation. Okay, now the second one. Let's go ahead and look at the second scatter plot. You can see that all the data is kind of trending from here to here, right? Therefore, this would be a positive correlation. It has a positive slope, so it would be a positive correlation. And then for the scatter plot for number 3, you can see it has a negative slope, therefore it has a negative correlation. So we would write down negative correlation. Okay, for the next part, you will be doing linear regression on the calculator. And before we get into these steps that are right here, I want you to set up your calculator. So what you're going to do is go to second, press second, and then the 0 button. And then from there, you are going to go down to where it says diagnostic on. It's kind of far down there. So go ahead and just press your arrow down to where it says diagnostic on. I'm looking for it right now myself. So keep going down. It's all in alphabetical order. Once you find it, you're going to press enter. And you're going to press enter a total of 3 times. So after that, you're going to press enter again. And one last time, enter. So you should have enter. And it should say done. It should say the word done. Once you hit done, then you are done. It is set up. Okay, now let's proceed to the directions right here. You will go to the word stat and then go down to number 1 where see how it says edit, and then number 1 should have the black, should already have be blackened. So you're going to press enter. And you're going to go under L1. So the next step says enter X values into L1 and Y values into L2. And it says if you already have values in there, which if you do, then this is what you would need to do, which I'm pretty sure you wouldn't because you probably haven't used this. But if you do, go ahead and clear those values following those directions. And again, you're going to use the X and Y values that you see right down here for 4A. Okay, so under the L1 column, you will put those X values, and under L2, you will put those Y values. Okay, once you do those values, so once you enter the number, then press enter, enter, enter. Then you're going to go to second mode, which is this next step right here. Second mode to go to the screen, excuse me, and to the home screen. Then after that, you're going to go back into stat. So now we're on the next steps. Press stat. Then you're going to press the arrow over to where it says CALC, calc. And then go down to number 4 to where it says, it looks like, it says for short for linear regression, AX plus B for a linear regression. And then from there, you will go down, put your arrow down to where it says the word calculate, and then you'll see the word calculate blinking. Press enter. And now it says your Y values for slope are A. So where you see A and that number next to it, that is your slope. The y-intercept is B. So where you see B, that's your y-intercept. That will be given to you on right here, as well as the value of R. So you're going to use the one that says R, not R squared, but just R, just like that, just R by itself. Now I want you to write your equation in slope-intercept form for y equals AX plus B. So let's go ahead and write down what we found on the calculator. So our slope, which was our A, is 43.66. Our y-intercept, which is B, was negative 140.50. Our correlation coefficient is the R, and that is 0.88. And our regression equation is, we're going to use all those values they gave us, is y equals 43.66x minus 140.50. It says, is this a good equation for the data? And how do you know? Well, the answer is yes, this is a good equation. So let's put this is a good equation, or good fit. We'll just put a good fit because, because R equals 0.88, which is close to 1. So if you remember when we were looking at the correlations at the top, it was either close to positive 1 or negative 1 or 0, which there is no correlation, but we were looking for negative 1 or positive 1. Well, in this case, we can see that it's a good fit because it is close to positive 1. Okay, let's go ahead and you will do the letter B and letter B on your own. You will enter those values again. You go into stat and then your L1 column, put in those X values. In your L2 column, put in your Y values. So I'm going to go ahead and work along with you right here. So go into stat, then go to edit, and in that L1 column, excuse me, I'm battling a cold here. In the L1 column, you will enter in your 0, enter 1, enter 2, enter 3, enter 4, enter 5, enter 6, enter 7, enter. Then go to your L2 column. 280, enter. 295, enter. 322, enter. 395, enter. 425, enter. 471, enter. 511, enter. And 548, enter. Now we have that. So we do our second mode. And then now we go back into stat, but we go to calc and we go down to number 8, which is linear regression you go to number 4. Erase that. So we go to number 4 where it says linear regression AX plus B. Press enter. Use arrow down to the word calculate. And we have our answer right here. So our y equals, our slope is 40.87. Our y-intercept is 262.83. Correlation coefficient is 0.99. And our regression equation is y equals 40.87x plus 262.83. Is this a good fit? Yes. So yes, because R, let's write that again, because R is close to 1. Okay, let's do number 5. So we're going to go back into stat, edit, and again, we need to clear that. And remember, you clear that by going up to L1, use the arrow up to L1, press the word clear, and then press the word enter. Then go to L2, press the word clear, press the word enter. So now go back to the first square under L1, and now let's go ahead and put in the information we have here. Now here we aren't given our X's and Y's in a chart like we were in the first couple that we did, but we can see what our X is and our Y, right? We do have some X's and we do have some Y's. So I can see my X's here would be -4, and then enter, and then my other X would be that 3. So I have X is -4, X is 3. So let me put 3 in the calculator. Now I'm going to go to L2. L2, I'm going to start with y's, and we're going to do them in the same order we just did. So we're going to do 12 and then -2. So 12, enter, then -2, enter on the calculator. Then second mode, we're going to quit, go to stat, then go to calc, go down to number 4, and go down, arrow down to the word calculate, press enter, and here we go. We have our answer right in front of us. Our slope is A, which is -2. Our y-intercept is B, which is 4. And our R, our correlation coefficient, is -1. Therefore, our equation here is y equals -2x plus 4. Therefore, is this a good fit? Is this a perfect fit? Yes, it is. So we'll put yes because R equals -1. So yes, it is. It's actually a perfect fit because R equals -1. Okay, let's go ahead and do letter B. Again, let's identify our X and our Y. So we have our X and our Y, our X and our Y. So we're going to go back into stat, go to edit, and let's clear that column. So make sure you arrow up to L1 and go ahead and press clear, enter. Then go to L2, highlight L2, press clear, enter. So L1 will be our X values. Our X values here, as you can see, are -2 and 4. So let's put in -2, enter, 4, enter. Let's go to L2. Our X value, or I'm sorry, our Y values are -1 and 3. So let's enter -1, enter, 3, enter. Second mode, which is second quit, and go back into stat. And again, we're on the calculator. Now we're going to go to calc, go down to number 4 for linear regression, and then you're going to scroll down to calculate, press the word enter, or press enter. Now you have your slope. Your slope here should be 0.67. Yes, it is a 6.7 right there. And then you have your y-intercept is 0.33. And your correlation coefficient here, R equals 1. Therefore, our regression equation is y equals 0.67x plus 0.33. Is this equation a good fit for the data? We're going to say perfect fit. Perfect fit because R equals 1. And let's go back to number 5, A, and let's go ahead, instead of putting yes, let's put perfect fit on there. Well, okay, I'm just going to write it right next to it, perfect fit. So if we get a -1 or a +1, that is a perfect fit for the data.